I'm going to discuss very interesting topic which is improper integration. And before starting this topic, I want to say one thing. After long gap, maybe 2 years of gap, I'm posting this video. This topic is in first year BTech. If any student wants the live class feeling, you can follow my videos. From now onwards, you will get my videos regularly. So please don't forget to subscribe my channel. And coming to the topic, this is improper integration. So what is the use of improper integration? Why you are learning this topic in BTech? Let me introduce this topic. Suppose the integral a to b f of x into dx, for which either the interval of integration is not finite. Suppose the lower limit a equals to might be infinite, or the upper limit b equals to infinite, or both the limits of a and b are not finite. That means it may be infinite. So that type of integral is nothing but improper integral. That means the interval of integration may be infinite, or the function f of x is unbounded at one or more points in closed interval a comma b. That means suppose the interval of integration may be finite, but the function of the interval is f of x is unbounded at one or more points in closed interval a comma b is called an improper integral. For suppose for taking look at the example, first example, integral 0 to infinity dx by 1 plus x to the power of 4. Observe this example. Here the limits of the integration, upper limit is infinite. So this is improper integral. This example comes under the improper integral of the first kind. First kind means the interval of integration may be infinite. And next example, integral minus infinite to infinite 1 by 1 plus x square into dx. In this also the interval is not finite. So these type of examples comes under the improper integral of the first kind. Now second example, integral 0 to 1. Here the limits are finite. 1 by 1 minus x square into dx. So 1 by 1 minus x square is unbounded in the closed interval 0 comma 1. See, suppose if you take x value is 1, 1 by 1 minus 1. So what you get? 1 by 0 infinite. So the function is unbounded in closed interval 0 comma 1. So this is also improper integral, but this comes under the improper integral of the second kind. So these are the improper integrals. These are the examples of improper integrals. So this type of integrals also we can solve by using beta and gamma functions. This type of improper integrals also we can solve by using beta and gamma functions. Now see what is beta function. The definite integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx is called the beta function. If anybody wants to take the notes, you can follow. Okay. So beta function, the definite integral 0 to 1 x to the power of m minus 1 minus x whole to the power of n minus 1 into dx is called the beta function. Here observe it, the limits are 0 to 1. The integrable function be x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx is called the beta function, and it is denoted by beta of m comma n. It is denoted by beta of m comma n, and it can be written as beta of m comma n equals to integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. This is called the beta function. Beta of m comma n equals to. So see, first term is m. So m is the power of x to the power of m minus 1. So second one is n. n is the power of 1 minus x, n minus 1 is. So the property of beta function is symmetric property, which is beta of m comma n equals to beta of n comma m. So proof. We know that beta of m comma n by the definition. Beta of m comma n equals to integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. By the definition, we know that beta of m comma n what it is. Now we have to prove that beta of m comma n equals to beta of n comma m. That means m should be changed as n and n is replaced by m. Okay, so we need to get beta of n comma m. So n is replaced by m is replaced by n. So the power of m by n, the m minus 1 base should be 1 minus x and n minus 1 base should be x. So these should be changed. So in the place of x, it has to be 1 minus x. In the place of 1 minus x, it has to be x. So for getting that, I am taking the substitution x equals to 1 minus t. Okay, this is the substitution which is x equals to 1 minus t. Put x equals to 1 minus t. I am changing x variable as in terms of t by taking x equals to 1 by t. Dx equals to minus dt. Immediately change the limits. Now we have to change x limits into t limits. What is the x limits of lower one? X equals to 0. X equals to 0, put in x equals to 1 minus t. So 0 equals to 1 minus t, that implies t equals to 1. So upper limit. What is the upper limit of x? 1. So now put 1 equals to 1 minus t. So that implies t equals to 0. Now substitute all these in equation number. So take the definition as 1. Now therefore from 1, beta of m comma n equals to integral t equals to lower limit 1 to 0 x 1 minus t whole to the power of m minus 1 into 1 minus, what is x? 1 minus t whole to the power of n minus 1 into minus dt. Dx means minus dt. So take this minus, write minus before. So t equals to 1 to 0. 1 minus t whole to the power of m minus 1. So 1 minus 1 get cancelled. Minus of minus plus t to the power of n minus 1 into dt. We know that minus integral of b to a into f of x into dx equals to integral a to b f of x into dx. We know that this basic one. So integral t equals to 0 to 1, 1 minus right front t to the power of n minus 1, and this is n minus 1 into 1 minus t whole to the power of m minus 1 into dt. Now observe this beta of m comma n in the definition. The definition is written, the integrable function is written in terms of x. Integral 0 to 1 x to the power of m minus 1, 1 minus x whole to the power of n minus 1 into dx. Same we can write beta of m comma n in terms of y in terms of t. If we want to write beta of m comma n in terms of y, you will get 0 to 1 y to the power of m minus 1, 1 minus y whole to the power of n minus 1 into dy. Same way we get beta of m comma n in terms of t. So 0 to 1 t to the power of n minus 1. So the base of n minus 1 is t. So you have to write beta of n should be first. 1 minus t whole to the power of m minus 1. The base of m minus 1 is 1 minus t. So we get, by the definition of beta, we can write beta of n comma m. So finally we get beta of m comma n equals to beta of n comma m. So hence the symmetric property is proved. So everywhere when we are solving the beta problems, if anywhere we want So you have to remember that beta of m comma n equals to beta of n comma m. Now coming to the next property, which is very important property this is, which is beta of m comma n equals to integral 0 to pi by 2 sine to the power of 2m minus 1 theta into cos to the power of 2n minus 1 theta into d theta. So before that we have 2. 2 into 0 to pi by 2 or integral 0 to pi by 2 sine to the power of 2m minus 1 theta into cos to the power of 2n minus 1 theta into d theta equals to, we can write beta of m comma n by 2. Both are same statements, both are same. So now we are going to prove the statement. What we know? We know that beta of m comma n equals to integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. Take this is equation number 1. Now here in this x should be converted as sine theta and 1 minus x, in the place of 1 minus x we need to get cos theta, and the limits 0 to 1 has to be changed into 0 to pi by 2. So to get this sine theta, observe this definition and problem which we have to prove. Both you observe that. So x we have to convert it into sine. In the power m minus 1 is here. Here there is 2m minus 1. So what is the substitution? Which one we have to take? Put the substitution must be x equals to sine square theta. So now dx equals to 2 into, what is the derivative of sine square theta? 2 sine theta into cos theta into d theta. Now change the limits. Now convert x limits into theta limits. Lower limit. What is the lower limit? X equals to 0. Now substitute x value 0 here. 0 equals to sine square theta. That implies theta equals to 0. Sin theta equals to 0. Theta equals to sine inverse of 0. So sine inverse of 0 is 0. Upper limit. If what is upper limit of x? 1. That implies 1 equals to sine square theta. So theta equals to sine inverse of 1. So sine inverse of 1 means theta equals to pi by 2. Now substitute all these in 1. From 1. Beta of m comma n equals to integral theta equals to, what is the lower limit? 0 to pi by 2 x. In the place of x, what should you write? Sine square theta whole to the power of m minus 1. 1 minus x means sine square theta whole to the power of n minus 1. What is dx? 2 sine theta into cos theta into d theta. So 2 is the constant, you can write friend. Theta equals to 0 to pi by 2 sine to the power of 2m minus 2 theta. 1 minus sine square theta is cos square theta. So cos to the power of 2n minus 2 theta into sine theta cos theta into d theta. So sine to the power of 2m minus 2 theta into sine theta. What you get? 2 into integral 0 to pi by 2 sine to the power of 2m minus 1 theta. In the same way, cos to the power of 2n minus 1 theta d theta. Okay. So therefore, finally we get beta of m comma n equals to 2 into integral 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta into theta. Hence it is proved. This is very important statement. You should remember beta of m comma n equals to 2 into 0 to pi by 2 sine to the power of 2m minus 1 theta cos to the power of 2n minus 1 theta d theta. Next, third statement, beta of, third form, beta of m comma n equals beta of m comma n equals to beta of m plus 1 comma n plus beta of beta of m comma n plus 1. We have to prove this. Now, to prove this statement, we are considering from the RHS part. Now we consider the RHS. RHS equals to beta of m plus 1 comma n plus beta of m comma n plus 1. This equals to, by the definition, how can you write beta of m plus 1 comma n? Integral 0 to 1 x to the power of m minus 1 in the formula. In the place of m, what it is here? M plus 1. So m plus 1 minus 1 into 1 minus x whole to the power of n minus 1 into dx plus integral 0 to 1 x to the power of m minus 1 1 minus x whole to the power of n plus 1 minus 1 into dx. Now this equals to integral 0 to 1 x to the power of m 1 minus x whole to the power of n minus 1 into dx plus integral 0 to 1 x to the power of m minus 1 1 minus x whole to the power of n into dx. From the both the terms, now I combine these two because the integration, the limits are same and integration is also same with respect to the same variable which is x. Now I can combine these two integrals as x power m into 1 minus x whole power n minus 1 plus x power m minus 1 into 1 minus x whole power n into dx. Make it as single integral. Now from these two terms, you just take common x power m minus 1, 1 minus x whole power n minus 1 because we need to get beta of m comma n. So from these two terms, you just take common integral 0 to 1 x to the power of m minus 1, 1 minus x whole to the power of n minus 1. If you take common this from the both the terms, you'll get x plus 1 minus x into dx. So x minus x get cancelled. Finally, we get integral 0 to 1 x to the power of m minus 1, 1 minus x whole power n minus 1 into dx. This equals to beta of m comma n, which is LHS. Therefore, beta of m plus 1 comma n plus beta of m comma n plus 1 equals to beta of m comma n. Hence, this is proved. Next one, fourth one. Here from this we call it as other forms of beta function. Other forms of beta function. So now this is very important form 1. Every time in the JNTU examination, 80%, if you observe the previous question paper, 80% this question is there. Beta of m comma n equals to integral 0 to infinity x power m minus 1 by 1 plus x whole to the power of m plus n into dx, that are equal anything. Integral 0 to infinity x to the power of n minus 1 by 1 plus x whole to the power of m plus n into dx are integral 0 to infinity y to the power of n minus 1 by 1 plus y whole to the power of m plus n into dy. Okay. Now proof. See, we know that beta of m comma n equals to integral 0 to 1 x to the power of m minus 1 into 1 minus x whole to the power of n minus 1 into dx. Okay, now this is the definition. We know that. So from this we have to prove integral 0 to infinity x power m minus 1 by 1 plus x whole to the power of m plus n into dx. See here, see this is the very important one. Beta of m comma n equals to integral 0 to infinity x to the power of m minus 1 by 1 plus x whole to the power of m plus n into dx. We know that beta of m comma n definition integral 0 to 1 x to the power of m minus 1 1 minus x whole to the power of n minus 1 into dx. So we have to change the limits 0 to 1 into 0 to infinite, and x to the power of m minus 1 in the denominator 1 minus x has to be replaced into denominator part as 1 plus x. So for the reason I am taking the substitution x equals to 1 by 1 plus t. So x equals to 1 by 1 plus t, dx equals to minus 1 by 1 plus t whole square into dt. Now change the limits also, lower limit. What is the lower limit in the equation 1? Now we have to change equation 1 into our form. So if what is the lower limit? X equals to 0. X equals to 0, substitute here, we get 0 equals to 1 by 1 plus t. Change it as 1 plus t equals to 1 by 0. So 1 by 0 is infinite, t equals to infinite. Upper limit. So if upper limit x equals to 1, so 1 equals to 1 by 1 plus t. So that implies 1 plus t equals to 1, t equals to 0. So lower limit is infinite and upper limit is t equals to 0. Now substitute all these values in the definition. So therefore beta of m comma n equals to integral. What is the upper limit? What is the lower limit? Infinite to upper limit 0. X. X is nothing but 1 by 1 plus t. X to the power of m minus 1 into 1 minus x 1 by 1 plus t whole to the power of n minus 1 into dx. What is dx? Minus 1 by 1 plus t square into dt. So now here minus is there. So write minus integral infinite to 0. So 1 by 1 plus t whole to the power of m minus 1. Now take LCM. 1 plus t minus 1 by 1 plus t whole to the power of n minus 1. 1 by 1 plus t square into dt. So this equals to, we can write 0 to infinity 1 by 1 plus t whole to the power of m minus 1. So now minus 1 plus 1 get cancelled, t to the power of n minus 1 by 1 plus t whole to the power of n plus 1 sorry n minus 1, 1 by 1 plus t whole square into dt. Now integral 0 to infinity t to the power of n minus 1, denominators 1 plus t, 1 plus t, 1 plus t same, 1 plus t to the power of bases are same. So now you can add power minus 1 plus n minus 1 plus 2 into dt. So we get integral 0 to infinity t to the power of n minus 1 by 1 plus t whole to the power of m plus n plus n minus 1 minus 1 minus 2 minus plus 2 get cancelled dt. So now this is in terms of t. Now same beta of m comma n equals to, we get beta of m comma n equals to integral t equals to 0 to infinity t to the power of n minus 1 by 1 plus t whole to the power of m plus n into dt. Same we can write in terms of x if we want, integral 0 to 1 x to the power of n minus 1 by 1 plus x whole to the power of m plus n into dx. Now Since beta of m comma n equals to beta of n comma m. So we can write integral x equals to 0 to 1 x to the power of n minus 1 we can write as x power m minus 1. 1 plus x whole to the power of m plus n into dx. This also we can write it as in terms of y. See, based on the statement in the given in the question you can write. So based on the question, if they ask this statement also in the question, we can write in terms of y integral 0 to 1 y to the power of n minus 1, 1 plus y whole to the power of m plus n into dy. So this is the topic for today. So if you like my teaching, you can subscribe my channel and follow my regular videos. Thank you.